getting 2.5 volt off a 5 volt source, so it's split very nicely. We're going to do a parameter sweep now. Okay. Just turn V2 off. Okay, so we'll get our cursors in here, and we can see that right at this point is where it reaches its maximum voltage, which is about 2.5 at about 107 ohms. And then now we have our current here at 26 milliamp at the same time, and then it gets shorter and shorter and shorter. Okay, and then we have our lowest voltage at about 400 millivolts to 2.5 millivolts, which looks beautiful. Get rid of this and we'll do a current reading with 6 mega ohm. Okay, and we'll do a reading for this. See what sort of current we're getting, and it's really, really low, right at about 666 nanoamps, which is not detectable with a traditional voltmeter. Now we're just going to run over our physical results. So on the physical circuit, as you can see here, this is our voltage divider coming in through here, then going into the op amp right here through the 5 volt power supply right there. And then just measuring it with some alligator clips, we've got 2.49, which is very, very close to 5 volt. Coming out of that, we have our maximum. So we have the photos here, actually the wrong one, it'll be this one here, where we started off at 10, and then 10 ohm resistor, and then gradually moved our way up. And then I will show you the Excel spreadsheet of it all graphed out. As you can see there, we got 2.47, and then we eventually get to our 5 volt 2.48, which is very, very close. So then it's all graphed right here. As you can see, 10, 22, 47, and we had 10 data points here with the voltage and current, and we got a graph very similar to the one we got in Simulink with our maximum voltage occurring at around about 100 ohms of resistance. And then as you can see, our maximum current is 26 amps. And then we see 38, but that's before the maximum voltage. Our minimum voltage is 370 millivolt, and then our maximum voltage is 2.48 volt. Finally, we have our 6 mega ohm resistor. So as you can see, we got 6 1 ohm hooked up in series, and then we have our voltage divider right here, and then we're just measuring the input current bias. And as you can see, as we discussed, it is extremely low. On Simulink, it was 666 nanoamps, and the voltmeter that I have only goes into microamps. So that's a good sign. That means everything's working well. Now we're comparing the values between the real and simulated values. Oh, no. So we have our real value is 2.9, 2.49. It deviates by not that much. It's very, very close. Even with the max current output, 26.2, 26.3. Very, very close to each other. And I feel where the simulated version 1 was with the very, very low values in the nanoamps, because the input impedance is so high, the current is so low, and traditional multimeters cannot pick up current values that low. So we got 0.0 milliamp, but really the simulated value was 666 nanoamps. Comparing this to the data sheet for the 741, we're looking at the output voltage swing. Now our value of resistance where we got our highest voltage was 106. So 106 ohms, sorry. And so here we have for 15 dual power supply, and at a minimum of 10 volt, they're getting a max voltage value of at 2 kilo ohm. So for 5 volt, our maximum, so for 5 volt, our maximum, our load was 106 ohm for 5 volt. And so they have plus and minus here for dual power supply, but really that means 20 if you think about it. But yeah, we had 0 to 5.